Next one is Véronique Baroghel-Bouny from now Gustav Eiffel. Thanks, Véronique, for presenting here the French approach that you have used.
Thank you very much for this invitation to this workshop. I'm very happy to be here to share the idea on this topic with you. And I will start my presentation on durability indicators. And with this title, so durability indicators seems to be a relevant tool for performance-based assessment of durability and multi-level prediction of structural lifetime. So I will deal with various aspects in this presentation. I will start with an introduction, and then I will focus on the definition and characteristics on durability indicators. I will then continue with example of classes and performance-based specification, and say some word on service life prediction. And I will try to give you an overview of what we can do. So first, when we consider the basic issue for concrete structures, you can see on this scheme that there are several possible processes. They are often coupled, and corrosion is the main degradation we can have on structures. And of course, this can be linked to chloride ingress and carbonation. And an important point is to see that in general, in field condition, these processes are coupled with moisture transport, so which are drying and wetting cycles in general. So in order to see how these degradation are happening, as expected, the magnitude and the kinetics of these processes and of the degradation are linked to the microstructure and the pure transport properties and interaction between the aggressive species and the pore solution. So as you can expect, and this is what you mentioned until now during the previous presentation, this is completely expected that we will find durability indicators among these properties and characteristics of the material. And with regard to the durability of the structure and the assessment of prediction of service life, you will need two other tools. Of course, when you will deal with prediction, you will need a model. What type of model? Even the simplest type of model, but you will need a model in order to predict. And you will need what I will call here monitoring parameters. But this is the same meaning of other terminologies you used in previous presentation. But anyway, when you are here, I will talk about durability indicators, and for durability of the structure, I will talk about monitoring parameters, and for prediction of the model. So when you want to assess durability, you will have various purposes. First, from a pure material point of view, you can assess the potential durability of a given concrete, and in this approach, this is based on measurement of durability indicators in lab specimen, and you will need a system of classes. And you can you will be able to compare or rank several concretes. You can optimize the mixture. You can carry out quality control. So this is first level of durability assessment, and this is purely for materials. The second aspect is when you want to make a concrete mix design for a predefined structural durability, when you want to qualify some mixtures for a given structure in a given environment. And in this case, you will need so-called specification, and you will use DHIs, the same DHIs as is in case, in order to do this. And this is what you can find in design codes, standards, etc. And the third aspect, which is maybe the most complex, more complex, this is when you want to predict service life, both at the design stage or for existing structures. And so you can also have a diagnosis of your structure. You want to predict the residual lifetime of your existing structure. And in this case, you will need first in situ monitoring, and this will be based on monitoring parameters. So again, I remind you that this is at the structural level, and you can decide to extend the service life or to repair the structure. So with a given set of tools, so first the DHIs and also monitoring parameters or models, you have a multi-level approach of durability. So you can do various things. So in this approach, what are the so-called durability indicators? So first criterion, you need parameters with a theoretical relevance. What does it mean? This means that these indicators are key material properties with regard to the quantification and the prediction of durability. This means that this is the parameters you will find in the governing equations of the process you want to quantify for chloride ingress, carbonation, etc. And of course, you will find this in the models. And second criterion to have this durability indicator, this is a reliable and easy assessment. And you will need for this a grid lab test with appropriate accuracy, reproducibility, where you will need to perform on lab specimen or grid cores. And hopefully we have now a lot of standard test method. I will come back again on this aspect. So we can define a first type of durability indicators, which will be suitable to various types of degradation. And this is the set of durability indicators you define in this approach we developed in France a lot of years ago, and which have been more or less derived in other approaches now. And so this is the parameters you will find in the governing equation. So you will find, of course, the porosity. You will find transport properties because they are key parameters in the processes. And depending on what is your purpose, you will select among these set of parameters. You can need in addition some specific indicators for a given degradation process, for example, for frost damage. So you will need some indicators specific to this damage, ASR, sulfite attack, etc. And you will need, of course, additional parameter when you will use a complex parameter for prediction, but this is optional and you can select depending on what you want. So with regard to this approach, you will need a small number of parameters. And this is the same set, the so-called durability indicators, which can be used for the various purposes I mentioned before. And the first type of parameters which can be selected among these durability indicators, this is from a chemical point of view. And this is Portlandite content, since this parameter is involved in several various aspects of durability and degradations. We can mention leaching, ASR, of course, we can mention reinforcement corrosion. So we can, of course, select this among the durability indicators. And this is to show you that this is not only physical parameters, but they can also be chemical parameters. And there is another one, which is a very general parameter you will need for everything. For example, you can use it for global quality assessment of your material. You can control the production of concrete with it, and you can compute other durability indicators thanks to this parameter, which is very easy to assess. And you can use analytical formula to assess other durability indicators. Of course, this will be involved also in specification for durability. And of course, you will need it for service life prediction, since even for the simplest model you will use, you will need porosity. And hopefully we have easy determination for this very general and global parameter. You can use existing analytical formula or direct measurement, and there will be a future European standard test method for this parameter. And as you can see here, this is very simple to assess. You only need to write the specimen, and you will calculate the porosity. So the principle is based on Archimedes' principle. So this is a fourth point. This is very easy to assess. Maybe other durability indicators you are very familiar with. This is the chloride diffusion coefficient. And of course, you know very well the theoretical relevance of these parameters. And since they are involved in the laws describing chloride ingress. But you are in reality two coefficients. It is important from a theoretical point of view to distinguish. And the first one is involved in first fixed law of Nernst-Planck equation. This is a pure transport properties, and this is the parameter required for physically based models. The second one, maybe we know more this parameter. This is the apparent diffusion coefficient involved in fixed second law, sorry. And it is important to mention here that it includes binding, so it might be a more realistic description of the phenomenon. And this is the parameter you will find in empirical models based on F function. And you mentioned this parameter very often this morning in the presentation. So you are very familiar with. It is worth mentioning that anyway, if you assess one or the other, it's not a problem since there is a theoretical relationship between them, and the choice between these two parameters will depend on the purpose of the investigation. And they are linked in particular with the porosity, you can see here, and with the so-called binding capacity. So the binding capacity can be regarded as a durability indicators, but specific to chloride-induced corrosion, for example. I would like to give an example of how to use this in models. I will select here a model which is at an intermediate level, not too much simple and so too much different from reality, and not too much complex in order to be very easy to implement. So this is a model based on Nernst-Planck equation, which is summarized here, where you can see the important thing is you can see where the ionic diffusion coefficient are involved in the equation. And you can see that even in a model when you can include various ions, you can assess only the chloride diffusion coefficient. So this is very interesting. And you can assess using, for example, this law, the other coefficients. So it is very interesting. And also to see where the binding capacity or the binding isotherm, I'm sure you know, is involved. You can see here that this is involved in the so-called mass balance equation. So even in a very simple model, a purely physical model, you need this parameter. So this is to show you how these simple parameters can be used very meaningfully in models to make prediction. And you can see that you will need few inputs for this model: the porosity, of course, the effective diffusion coefficient, and this binding isotherm, or at least the binding capacity. And as I mentioned before, we have a lot of test method now. It is now well advanced, because some years ago we didn't have so many standardized test methods, but now we have. In particular, maybe the most used test is this one. This is non-steady state migration test covered by these standards. But you can use also non-steady state diffusion test covered also by this European standard. And it is also useful to mention that even if you have not direct access to these properties, with a resistivity measurement, which is also now covered by a standard test method, you can assess the effective diffusion coefficient thanks to this analytic law. And you can also assess the coefficient and the binding capacity by using models. So the biggest advantage here is that these parameters, effective or apparent parameters, can be easily accessible. I would like now to mention another one. You also mentioned this one this morning, which is, from a theoretical point of view, very important. Because, and as mentioned in the previous slides, we can deal with saturated condition. But in field condition, we usually are in non-saturated condition. And in this case, if you remember my first line, you need to combine the process you consider, for example, chloride ingress or carbonation or any other process, with moisture transport. And the difficulty is that in most of cases, you have cycle drying and waiting cycles. So you will need a parameter which is able to quantify moisture transport, and at least you will need liquid water permeability. And in particular, when you have chloride ingress in tidal zone, it is necessary to take this into account in order to be able to predict correctly chloride penetration for every type of concrete. So it is important to know that we can select this as indicator, since we can demonstrate the theoretical relevance of this parameter, since it is involved in Darcy's law, which is the main equation needed for the description of moisture transport in concrete. And you will require such a parameter or any other one which is theoretically correlated with this indicator when you will need to describe or to predict moisture transport or coupled transport, so for example, carbonation or chloride ingress in field condition. And in this case, we have also various methods, but it is important to know that the direct measurement is more difficult, but you can use some assessment by analytical laws, by some simple models, or of course used specific experimental devices. So what to do with these durability indicators? First, you can find them in classes in order to assess potential durability. I will not take too much time to deal with this because there are already previous presentation dealing of this. This example is directly drawn from what we did when we developed in 2004 the approach in France. And so for each selected durability indicator, we define classes, some in order to decide of a very low or a very high potential durability, for example. And I would like to mention here that for these durability indicators, I only deal with properties measured in lab with appropriate standard deviation for of course, and also with well-defined protocols. Of course, this is only an example of how it works, but there are several other system of classes proposed in the literature, and you can find them and select the most adapted, of course, on the problem. And now there are some standard working on this aspect, and very soon I hope that we will have generally accepted classes for this. So you can assess the potential durability according to each indicator, but you can also do this on the basis of an overall weighted weighting, and this will be very interesting and very efficient with regard to concrete with ASTMs. And I would like to give an example on this. This is a set of concretes. They are ranked here according to their 28-day compressive strength. And the measurement was made with the most often measured durability indicators: the porosity, the gas permeability, diffusion coefficient, and you can see here, depending on the color, you can assess the durability based on only one parameter, or make an overall potential durability. And in this example, we select the same weight for each DI, but you can see that depending on all the parameters, you will have unexpected evaluation of the potential durability. For example, you can find only medium durability for high performance concrete due to not very good gas permeability due to air entrainment in this case, or you can have an expected high durability, for example, with this material with fly ash, thanks to very good performance in chloride penetration. So you can see that when you select properly your set of durability indicators, you can focus on what is important for you with regard to the environment you want to consider, and you can see clearly the benefit of ASTM concrete. So this is the example of durability indicators used for specification. maybe I can go directly to the other part because this you are very familiar with. In this case, you will need not only selected durability indicators, but also type of environment and the requirement level. For example, 100 years for the lifetime. And when both the aggressiveness of the environment and the target service life will increase, you will need to check a greater number of parameters, and the criteria are more stringent. I would like to summarize this methodology. So to assess the potential durability, you will need the durability indicators, you will need the classes, and you will compare to assess the durability. And when you want to select to accept a mixture for a given structure, so we go to the structural level here, you will need in addition specification. I would like to, before finishing, give you example of what mean prediction in this case. So when you want to predict service life or transport process, you will need first a durability indicator as input data for the model. So this means that this is the main input data of the model. And included in the model, you will need some laws which relate the DI with temperature, relative humidity, etc. When you will want to go to durability, you will need to calibrate the model, and you will need to measure the durability indicators in given exposure time, and then you can calculate, if you remember what I call the monitoring parameters, and it can be the kinetics of penetration, it can be profiles, and when you want to predict, you will make some prediction thanks to this monitoring parameters. So first, there will be the output of the model. So the model will provide this calculated monitoring parameters. And when you want to compare with existing structure, you will compare the calculation with what you will measure in real condition. So you will need to measure the monitoring parameter in situ on your structure. And this is the diagnosis you can do. So you can make prediction at the design stage. You can make the diagnosis thanks to this measurement. And you can also predict the residual lifetime. So this is a complete approach. And this is what I mean when I mention monitoring parameters. So in this approach, the monitoring parameters are the parameters which help to quantify the durability. So carbonation depth, chloride penetration depth, moisture profile, carbonation profiles, or chloride concentration profile. So this is the so-called monitoring parameter. Maybe I can go directly to the conclusion if I have no time to continue. Maybe one word on the model. So in order to summarize what you need with the model, you can use any type of model. Of course, it's better if it is at least physically based. You can use models within deterministic or probabilistic framework. And of course, they need to be suitable to such performance-based approach of durability. And in this model, your durability indicators will use as input data, and your monitoring parameters will be used in order to compare with the experimental data and in order to validate the models and to compare with real situation. I will go directly to the conclusion. The other one was an example with carbonation, but I can go to the conclusion. In order to identify clearly what are included in this approach, when we develop the approach, we develop a whole toolkit for this, where durability indicators are here, the monitoring parameters are here. We need also predictive models when you want to make prediction. And of course, you need also specification in order to select appropriately the durability of the structure. So you can see that this is a toolkit, which is based on a set of key material properties in particular. And it is scientifically based, but it is easy to use because the tools can be, you can select the simplest tools included in this toolkit. And in order to be able to identify the most important things, I would like to mention that in order to avoid any confusion, durability indicators are different from monitoring parameters, and you need separate measurement from this, in particular when you want to make prediction. If not, you demonstrate what you put in the model. And for the model, of course, you need several stages to be able to make really prediction. And for example, when you want to quantify carbonation, the main input data required by any model, even the simplest model of carbonation, is the porosity and the initial Portland-like content. And for chloride, this is the porosity and the ionic diffusion coefficient. And when you are in non-saturated condition, which is the usual case, you need also transport properties able to quantify moisture transport, and the most relevant is liquid permeability. And so you can see that these parameters are needed even when you use a very simple model based on square root of time. For example, you need at least porosity and one additional parameters. So of course, you know the advantage of approach based on level of performance. So you have, of course, greater freedom, and you can easily use new concept of mid-design. And I think that it is very interesting for people in order to include this in model codes or in standard. So I can answer to your question, of course, but this is to go directly to the end. So thank you very much for your attention. I would be happy to help you to understand this approach if needed, but thank you again for your attention.
Thank you, Véronique. I have a question from Kefei Lee in the Q&A that is saying if the Portland dye content is still regarded as durability indicator if alternative binders are used.
I can answer easily to this. If you look at, it depends on the process you look at, since it can be necessary. For example, I didn't show the model on carbonation, but what I mentioned at the beginning is that if you have, for example, a low clinker binder in your concrete, if you cannot use the calcium Portlandite in the carbonation model because it's close to zero, you will need to put in the model the CSH content, which can be a little bit more difficult to assess. But in any case, it depends clearly on the process you need to assess. And the best in the model, in the carbonation model, I have example in the presentation, you need both if you come back to Papadakis' model, which is very famous and very simple, you need both. You need Portlandite content and you need the CSH content. So anyway, you need something to put in your models in this case, and it depends, of course, on the process.
Yeah, and there is another question that I ask, please, to respond short, Veronique, is from Alexandra Costa. There, Veronique, I would like to know if the durability indicators provide some path to monitoring parameters. What is the connection between those?
It is clearly the models, because durability indicators are the input data of the model, while the monitoring parameter are the output. So when you want to make prediction or a diagnosis of your structures, this is clearly what you compare. You will be able to compare the prediction of the model. For example, the model will provide a chloride concentration profile, and you need to measure this monitoring parameter, which is the chloride profile, in the field condition or in lab condition, depending on what you include in the model. So this is clearly how to quantify directly the durability. And this is from a structural point of view. The durability indicators are only measured in this approach in lab, but of course you can compare with in situ measurement. So this is the two extremities of the model.
Okay, thank you, Veronique, very much.